being recorded. Bird is the word. He is here. Scale drawings, models. I got to write down that you're here though before I move on. And we will continue. Here. Okay, let's take a look at these examples here because the math part of it isn't new. It's still the same cross multiply, divide by the loaner type of math. So let's read and interpret this stuff. The ratio of the length of the width of a rectangle is 5 to 3. When you see the dot dot, it means 5 to 3, like that's how we usually say it. Right? So 5 to 3. If the rectangle is 24 centimeters wide, how long is it? Well, the first thing is have you guys ever seen ratios written like that? Yeah, you have? I think of them better as fractions because once I make it a fraction, you know how to solve this. If I say the ratio of the length is 5, I'm going to put a little L beside that so I can keep to the width of the rectangle. 3 is the width. I'm making my ratio into a fraction, so will you in your paper at this moment. Now, with that set up like this, you can solve pretty well any problem. Let's read again here. If the rectangle is 24 centimeters wide, how long is it? You want to find the length if it's 24 centimeters wide. What do we do with the 24? Top or bottom of this side? On the bottom because the width is matching on the bottom of it. So 24 centimeters. And we want to find the length. I'm going to use the letter X because you're familiar with it, but everybody understands that to be the length. What would you enter in your calculator? 5 times 24. That's the cross multiply. Same as always. Divide by the loaner, 3. You got your calculator good? Wait for the answer. 40 it is. Good work. So X is equal to 40. Not just 40 though, it's centimeters. Because we had 24 centimeters, we've got to use the same unit. So it's 40 centimeters long. That's every chapter so far. I've only used the same type of equation. We have not learned any new mathematical skills. Honestly, this is more of a reading course, isn't it? The whole sines and cosines every time turned into one of these math things, right? Just hit a button on the calculator. Cross multiply, divide by the loaner. The math isn't confusing, it's the reading. We can work on this because, well, we're doing a good job here. You guys are doing a good job on it. Now the ratio of Tom's age to Mary's. Tom to Mary is 3 to 4. To write a fraction, I'm saying 3 to 4. Put a letter T or an M. Which is the 3? Is that Tom or Mary? That's Tommy. Tommy boy. Tom to Mary. Now, how do we fill in the other side of this problem? If their ratio is 3 Tom's age to 4 Mary's age. Tom is 15. How old is Mary? Okay, you're miles ahead of us. Good. So Tom is 15, so 15 is what we put on the top. Cross multiply, 4 times 15. Divide by that loaner, 3. You've got 20 as the age. Good. I've heard a couple people say that. 20 years. Oh. It's good to put an explanation in there. You know, Mary's 20 years old or something like that. Mary's 20. Just so you remember, am I solving what I'm supposed to? The math is not tough. I think you all agree. It's just the reading. How about this one? Set up a ratio. I'm going to let you guys set it up. 355 kilometers per 7 hours. How much distance in 8.5 hours? I'll give you a second here. You already done? No. But you know what to do? You're not done yet. I'm just giving you a chance to do Georgina. Travels, that problem. You are awesome, young lady. If you want me, I can sign a note that says that you're awesome. You can take it, show it to whoever you need. So she has 431, 355 kilometers in 7 hours. That's what you're given. We want to find out how far she'll travel in 8.5 hours. We have the hours on the bottom. So she cross-multiplied 355 times 8.5, divided by 7. She got 431. 431 kilometers. So you can do speeds and distances this way, right? No problem. You can solve, I'd say 80% of this course using that. Cross multiply and divide by the longitude if you set things up right. As long as you keep reading correctly. And you guys are. The next page. I'm going to flip, right? So the next page is something you may have seen before, way back if you were attending well when you went to grade 7 or 8. How do we reduce fractions? Do you guys know what I mean if I ask you to reduce a fraction? 50 out of 75. What is that as a lower term? Okay, you know what we're talking about. What is it? 2 out of 3. Because you divided everything by 5 and then 25 and then I was going to say probably 5 again. So you looked, do you remember there's words, you don't have to know what they mean, but you divided by the biggest number possible in both of these, right? Do the words lowest common multiple, greatest common factor, do you guys ever GCF? You've heard of that? This is GCF, greatest common factor. You don't need to know it's the greatest common factor. Just think what's the biggest number that'll fit into both 50 and 75. She said divide by 25 both times. Okay. She's a whippersnapper, isn't she? So 50 divided by 25 is 2. 75 divided by 25 is 3. Likewise. Try 15 out of 25, try 24 out of 96. 15 out of 25 you could probably do just with a quick look up. The other one might be a little more, thinking about it. You might have to do it twice. You can reduce and then see, oh yeah, something else fits it. You can reduce again. I'll let you guys decide. I'll give you another minute for that. While you do, I'm going to pour myself some water. I'm not sure if I'll make it through the winter. Take good care of me, kids. Hot chocolate, marshmallows. 3 out of 5 because you divided both by 5. Good. Now the next one, you might have done in 2 chunks, or did you? What'd you get in your first chunk? 4 over 6. Okay, so you divided both by 6 then. So she divided both top and bottom by 6. I'm going to write that one down just because. You said divide by 6, divide by 6. No, what did you say? Okay. You're saying 24 divided by 6 is 4. What's 96 divided by 6? What is it? Oh, 16. I thought I heard something different. And then you divided top and bottom by 4, 1/4. Okay, good. Is there a quicker way? You could have done it in other chunks. You could have divided both top and bottom by 12 and then something else. You could have divided top and bottom by 24 and jumped straight to 1/4. It doesn't matter if you do it in 1 step or 2 or 3 steps. Did other people get 1/4 after 1 or 2 steps? Good. So if you see it right away, like often check with the top number or the smaller number. 24 does divide it to 96 4 times. Anyways, we got to know how to reduce fractions for some of these new problems. Look at this one. Scale statement and scale factor. I'm not going to worry too much about these things, which is the statement and factor. But do you guys see, here's my statement, scale statement. If the original is 6 centimeters, right, and the comparable sign on the model is 3 centimeters, I'm going to make a statement and say that that's 6 to 3, right? I'm even going to say 6 centimeters to 3 centimeters. You don't need the centimeters in there, but sometimes I like that. 6 to 3. Now, if that was a fraction, 6 out of 3, could you reduce it? Yeah. What number fits into both? Okay, 3 fits into both, and you get 2 and 1, right? So, what you're telling me is your scale factor is a 2 to 1 scale, right? 1 to 2, 2 to 1. Depends which one you want first, right? But the object is 2 times as big as the drawing, the model. Now, the other way around, sometimes, like, why would you ever want something that's small made big? Well, I know at the museum, just a few blocks down College Avenue, they have a thing with bugs or whatever. And bugs are really tiny, so they have a bug something like 20 times regular size. Those kind of things, if you want detail. So this is a 3 to 15. Does it matter if I use 2 to 10 or 1 to 5 though? It's the same drawing. Which one should I use? Is 3 to 15 a different ratio than 1 to 5? Yeah, you know what I'm asking? No, it's the same thing. So why not choose the smallest one right off the bat? Does that make sense? So then you can do both. I'll do it in blue because it's a scale factor. You've got a 1 centimeter to 5 centimeters, or 1 to 5 scale factor, or ratio you sometimes hear. Okay? Now, that one's just an easy one to do. How about C? This one doesn't have a drawing, but we've got to do some figuring. A man in a photo is 2 centimeters tall. That makes sense. His actual height is 1.8. So this is 2 centimeters to 1.8 meters. Tell you the truth, I find that the most useful way to give this, because you could set that up as a ratio and say he's 2 centimeters in the picture, in real life he's 1.8 meters, and then you can set up the other side, cross, multiply, divide. But we're asked for the lowest terms, basically the scale factor. You know how centimeters and meters, they're not exactly the same, but you can go from one to the other. I'm going to ask you a question, because centimeters are used most often. Seems like unrelated, but you might see my point here in a second. How many years are in 1 century? It's not a trick question. This century has 100 years, yeah? How many cents are in $1? 100. How many centimeters are in a meter? Then it's 100, right? Cent, something, Francais, or whatever. That's 100. That's what that means. And it means the same thing when you're talking about money, centuries, for years, centimeters. 100 centimeters. They're fitting in 1.8 meters. So, this in my hand is a meter stick. There's 100 centimeters between my hands, right? 1 meter is 100 centimeters. If 1 meter is 100 centimeters, can you do this in your head? 1.8 meters, is that a lot or a little bit of centimeters? It's a lot, right? If it was just 1 meter, it'd be 100 centimeters. If it's 1.8, can you do this in your head? 1.8 meters? 180 centimeters. Now, if you don't, like this is, I'm trying to see if you can reason this through. He's saying, yeah, 2 to 180. Now they're matching. I don't have to include centimeters. But if that didn't make sense to you, and it's fine if it doesn't, you could just say, well, I know there's 100 centimeters to 1 meter. There's X to 1.8 meters. If what I was talking about there didn't make sense, just think it through. But if you can reason it through and you just say 1.8 meters, that's 180 centimeters, just do it. You don't have to do this work here. You can if you're stuck. So on the right, the green stuff isn't necessary. Now, its actual height. Okay, the scale factor is 2 to 180. You can reduce that by a half, right? Everything halved. It's 1 factor of 2. A 1 to 90 scale, right? Does that make sense? Because you will see on blueprints and stuff like this, the scale of these things sometimes. Going like gangbusters, guys. I want to work with you on a little foot and inches thing. And then I'll give you some centimeters too for there's well, when you, some centimeters. When you need a ruler, there's one with a drawing program later, or problem with drawings. You can come up and get one when you need it. On a blueprint, a 1/4 inch equals 1 foot. I don't think the word quarter screws anyone up. You know that it's a 0.25 is a quarter, right? Decimal-wise. If you didn't, you just type it in your calculator. 1 divide 4. Any fraction can be a division problem if you want a decimal. Anyways, a 1/4 inch is a foot. Write this as a scale statement in that form, dot, dot, 1 dot, dot, x. So, if I have, well, 1, okay, let me see. 1/4 inch equals a foot. Just get a cough here. It's 0.25. You know how I use those double things for inches? Anybody not familiar with that? 1 foot. You know this because you've done construction, right? Is this new to you, Faith? No? Tia, you've seen this? AB, you've seen foot and inches like that? TI, yeah. Okay, nobody's confused what I just wrote down, right? Why did I write down an equal sign? Hack it up. Pardon me. Losing my voice and forgetting what I'm writing. Okay. Using the dot dot form, right? Scale statement that way. Now, I find that actually quite useful, but I think we're supposed to get it down to the lowest form because we're told to get it down to 1 to x. Do you guys off the top of your head remember 1 foot, how many inches in it? 12. If you didn't and you were on a test, I can give you some reminders. 12 inches in a foot, that's 3 feet in a yard, stuff like that. Don't worry. So, does it make sense that this is the same thing then? 0.25, I'm putting it in blue because we're kind of doing some extra work here. 12 inches to, that's the same statement, isn't it? Instead of a foot, I'm putting that down. Like, good gravy, Shindaka. Where's this going? How would you make a decimal 25, a quarter? What could you multiply that left side by to make it up to 1? Because we're supposed to get a 1 to x ratio. Pardon? Times this by 5, and you'll have more. 5/4. Yeah. I think I know what you're thinking, though. So how many quarters make a dollar? How many quarters make a whole? 4, yeah. 4 quarters. So if I multiplied both sides by 4, times by 4, I have to do it to this side. Does it make sense then? If a quarter equals 12 inches, then 1 would equal, well, 4 times 12 is 48 inches. I guess I don't need the inches on there, but I'll put it on. It's a 1 to 48 ratio. Does that make some sense? Sort of? Yeah. What I have in green I think is fine enough for most problems, but they actually specifically asked for a 1 to whatever ratio, okay? B, because here's why I like what I had in green. The original statement was, what's the actual length of the room? Gotcha, eh? If it measures 3 3/4 inches on the blueprint. Well, what I'm going to do is use that decimal 25 from the top. Decimal 25 inches to 1 foot. That's why I'm going back to the green. And that's why I like this test. I like the fractions better. Now, as a decimal number, 3 3/4, 3.75, right? 75 cents is 3/4. I'm going to say that's the inches side, so 3¾ inches. We've got to solve what's the actual length of the room. So in the little diagram, it's 3¾ Tia, I see some other people working away at this. This is good. 15 it is. That's what I got to. It's a 15-foot length on the real life, on the room. Now, some words about this. If you want to earn 80–90%, you should make sure you write down little statements too. What's the actual length of the room? A 15-foot length of room. You know, the room is 15 feet long. If you're just going for 60s, 70s, maybe, I'll even let you get 70s without writing full statements. You can go for it. But once you get into that 90s category, we're going to have to make sure you have full statements. Now, you've got just a few problems today. 7.8 meter object represented as being 1.5. What's the scale factor? This, the shoreline of Great Bear Lake, 2,719 kilometers, not counting the island. If that map is at a 3:100 kilometer, 3 centimeters to 100, how long is the shoreline? Do you have to use a ruler to measure anything on this map? No, just use the written words. It's just for interest's sake they got the outline of the island. This one here, though, you do have to use a ruler. And that's why I was saying, I got my box of rulers up here. You're welcome to come use them. Okay? The diagram below shows a house floor plan. The L wall in the actual master bedroom is 12.5 feet long. So this length is 12.5 feet. So then you would say whatever you measure, 5 centimeters, 5.3 centimeters, be accurate, 5.3 or whatever you get, is 12.5 feet. And then come up with your scale lengths and stuff like that. What is the dimension of the family? Things like that. Okay? I've done the problems too. So. They're doable. I'm going to stop the recording. We'll get going.